Hi ladies, in this video we're going to go through 7H, interpreting the slope and intercept of a regression line. So your regression equation is in the form y equals a plus bx. So a is what we call the intercept that crosses your response variable or your y-axis, and b is your slope. Okay, and you need to be able to interpret what they actually mean. So these are the definitions, so slope and intercept, but interpreting them is, a step further. You actually need to know what it's telling you. So you can say, well, the slope is 2, but what does that actually mean? All right, so you've got an example here. Let's just do some questions. It might be a bit easier. And let me get my Word document up. All right, so I'm going to do question 1. So the equation price equals 37,650 minus 4,200 times age can be used to predict the price of a used car from its age. All right, so we need to write down the value of the intercept and then interpret, write down the value of the slope and interpret, and then use the equation to predict the average price of a 5-year-old second-hand car. All right, so let's write down the equation. So we've got price, 37,650 minus 4,200 times age. Your intercept is always your constant. So your intercept, or your y-intercept, your value of A in your equation is 37,650. Now, when you're interpreting this, it is when your explanatory variable or your value of x is equal to 0. Okay, so when you're taught linear graphs, so straight line graphs, our x-intercept is when your y-intercept, which is what this is here. So your y-intercept is when x equals 0, or your explanatory variable is equal to 0. So basically for this one, what's your explanatory variable? Age is equal to 0. The price of the car, so we're doing cars. The car is 37,650. So this is basically a brand new car. So when the age is 0, so a used car, it hasn't been used yet, it's 37,650. And when you think about it, the cost of a car decreases with age, unless you have a fancy old car. I can't think of anything off the top of my head. Okay, so that's how you would interpret your y-intercept. When your explanatory variable, so in this case age, is equal to 0, the price of the car is $37,650. Okay, what is it at the very beginning? All right, so to interpret your slope, so your slope, which is the value of b in the equation, is 4,200. Oops, it's negative 4,200. Sorry, forgot about that. That negative just means it's decreasing. So when you have a negative b, it's decreasing. Okay, so just remember that. If it was b, it's increasing. So our slope is 4,200. So when you're interpreting this, you say for every increase in one, whatever the unit is, so in this case it's years, in 1 year, or years, for every increase in 1 year. Sounds a bit weird, but you could use this phrase for any variable. So we're doing for every increase in one, whatever the variable is. So for every increase in 1 year, or for every increase in 1 centimeter, or for every increase in 1 kilogram, okay, you always have an increase, and this is what you're measuring it in. So the one, whatever the measure is, it always increases, okay, because we're going along the x-axis. We're not going backwards. All right, so for every increase in 1 year, the cost of the car, now remember it's negative, so it's decreasing. Cost of the car decreases by 4,200. We don't write by negative 4,200. The negative is represented by the word decreases, and if it was a positive slope, you would have increases here. Okay, so those things would change. So this is decreases if it's a negative b. Okay, and in this case, we've got a negative b, but you write your number 4,200 because we've already accounted for that negative sign by saying it's decreasing. All right, let's have question C. You can do that's quite similar to the previous question. All right, let's have a look. I might just skip to question 4. Whoops. All right, so in question 4, it has been suggested that the blood glucose level of adults can be predicted from their weight. Oh, we did this before, didn't we? Interesting. 51 plus 0.62 times weight. All right, so for this regression equation, write down the value of the intercept. So remember, your intercept is your constant. So your y-intercept is equal to 51, and then we need to interpret it in the context of this problem. So remember, your y-intercept is when your explanatory variable is equal to 0. So basically, when weight is equal to 0 kilograms, the glucose level is 51. Okay, so when weight is equal to 0 kilograms, so kilograms being the unit we're measuring weight in, the glucose level is 51. And you can put the units in there, milligrams per 100 mils. Okay, so that's interpreting our y-intercept. Obviously, you wouldn't have a weight of 0 kilos, but that's what it was saying before. Sometimes in the context of the problem, it just doesn't make sense, but that's how you would interpret it anyway. All right, so your slope, remember, is your coefficient of your explanatory variable. So in this case, it's 0.62. So for every increase, so remember that the phrasing is the same in 1. This time our units are kilograms. So 1 kilo, the glucose level slope is positive, so it's increasing also, increases by 0.62, and you can write the units down in milligrams per 100 mils. Okay, so you can see the phrasing is pretty much the same. Okay, we're just changing it to, suit what the variables are. So this value here comes from your explanatory variable. Okay, so we're always going across for every time we go across, so that's your explanatory variable. We're either going up if your slope is positive or down if your slope is negative. All right, and then we're moving on to 7i, so I'll end there. Bye, girls.